Okay, it's been a full year since I've had my solar panels in place, so I want to give an update on the data for that full year. Um, if we go back to 2019, 2018, these are my years of electrical bills. I've calculated the approximate number of kilowatts per day that are used. Actually, um, yeah, kilowatts per day used. Um, you can see the differences in the orange up here is with the solar panels. I put in August or five solar panels that took place August 7th. So right in here is when I started with five solar panels, and then in October 7th I put in um, 10 solar panels. So this is the first, October to November is the first month I have with 10 panels. And then the September to October bill for 2020 is the last um, month that I had 10 panels. You can see my monthly kilowatts for these 2 years. These bottom three values are based on only having five solar panels. Um, and then the top are based on having 10. Now, these two right here, it shows less in 2020 used per day. Again, this is after net metering. So um, I've calculated how many kilowatts I used or were actually charged for, I should say, compared to 2019. I used almost one less kilowatt per day by adding the 10 panels. Now the difference here is the temperatures, air conditioning. So this data down here averages out those years. So you can probably assume in 2016 we had more air conditioning days than we did in 2018. Um, so then I take these two and average them. And the daily difference then after the panels, you can see that I have a much bigger daily difference in September and October after I have the 10 panels in than compared to when I had only five panels in. After the panels, there's my average 16.8, 16.1. Before my panels, I was having 24.4 and 18.6. And again, this average here is based on the idea that I'm not sure what happened in 2016 in September and October, but I'm guessing we didn't have much air conditioning running. And obviously in 2017 we did. I haven't gone back and put temperatures, average daily temperatures in, but I could, maybe I will. Anyway, to compare it to money wise, I have the savings per month at 11.1 kilowatts or cents per kilowatt hour. I am paid 4 cents per kilowatt that I produce, that my meter runs backwards. So I have my income. Monthly net gain is essentially $26, $25.91. So my projected months to pay off this is 95.56 months, which when you divide that by 12, it's real close to 8 years. So if you are able to wire your panels directly into your circuit box, I would have essentially saved close to $1,100 from this cost of panel installation, just because I wouldn't have had to pay for the box. I wouldn't have had to pay for actually the three boxes. And I would have been able to use my existing panel and probably save some wire costs. So now, if I lower that by $1,000, then that essentially cuts my cost by over 25%, let's say close to 27, 28%. So now that cuts my time by almost a fourth. So I would pay off my panels in less than 6 years. So there you go. There's a quick update. You can see the grand total up till now of my estimated savings from the panels. Total estimated savings here, average monthly savings. So making essentially $6 a month on my meter running backwards, and saving essentially $20 a month on the electricity that I'm using. Now, part of this has been because of the net metering, the way my REMC does net metering. No matter how much electricity I produce, when my meter goes forward, I'm charged 11 cents a kilowatt hour. When my meter goes backwards, I'm given 4 cents a kilowatt hour. So what I've decided is when the sun shines, I use as much electricity as I can. I try to have my wife do laundry. I try to do dishes with my dishwasher, and even maybe try to increase electrical heat somehow with a space heater or something like that. But when the sun's down, when I'm not using electricity from the sun, I try not to use the electricity from the power company. So thank you very much.